of the most important decisions that any home builder will ever make is to what level they're going to insulate and seal their home. And so many experts claim that that decision is second only to that of the heating and air conditioning system that you choose to put in your home. And as you get to thinking about that with rising utility cost and everything else, as Yvonne and I look at our home, we want to try to make the proper decision, especially considering that it's a whole lot cheaper to spend that money now than it would be later. So today I've assembled a team of experts to help us kind of walk through this decision-making process of what we're going to do with the insulation and how we're going to seal this and kind of go forward. Now I have with me today my general contractor, David Brookshire with Brookshire Homes. He's actually contracted with Mr. Barry Pierce, who's the owner and operator of Triple G Insulation, and also have with us Kalen Kelly. Kalen works here at Western Farmers. He's the commercial and industrial marketing manager, and he's the responsible entity for the whole Touchstone Energy Home program. So, Kalen, let's get this thing started. Why don't you go over and let's talk a little bit about the Touchstone Energy specification. And remember, I'm trying to build the first Touchstone Energy home in the state of Oklahoma, and I understand we have 3 levels, and I want to build the gold home. So tell me, and Barry and David, a little bit about our specs for that home.
Well, basically the specification for the Touchstone Energy home, since we're in climate zone 3, the main things that you want to specifically look at is the value of the R value of the ceiling, which is a 30 in zone 3. As well as in your walls, since your home's going to be built with 2x4 walls, you'll meet the criteria of R13.
Okay.
So the criteria for the Touchstone Energy specs will be R13. As well as the slab floor, but since you're in climate zone 3, that value is 0.
Mm-hmm.
But there's some things that you can do that we'll discuss at later points that you can do to also provide value with your slab floor as well. We'll also be looking at a air exchange, or basically we'll be looking at a HERS rating, and within that HERS rating, they will be looking at the amount of air exchanges that you'll achieve in a home, and they'll look at that as less than 3 air exchanges per hour at 50 pascals.
And that blower door testing that you're talking about, it's mandatory, correct?
That's correct. In this Touchstone Energy spec, it will be mandatory.
So it's something, as we consider this, we're going to have to make sure that we can meet that.
That is correct.
Thanks, Kalen. I appreciate that. We kind of now know the boundaries of what we got to be working within. David, I want to turn to you. This is probably an area when we were looking for a home builder that really separated you from others that we had visited with when Yvonne and I were talking to them. I have to admit, looking and understanding the pride that you put in that Brookshire home. So could you go over with us kind of a quick overview around this insulation level of what differentiates a home that you'd put the Brookshire brand on?
Well, one of the things I do is I build the 2x4 walls is what's required. I put the radiant seal down on the bottom of the slab between the plate, our green plate. Once the house is totally framed, sheathed in, everything's done on it, then I come in and I do what's called a super seal. And I have Mr. Barry's company do that. They come in and they caulk the base plate, the green plate, they caulk everything on all the exterior walls with caulking. So if there's 2 2x4s put together, then we seal in between those 2 2x4s. And then we do the top plates, everything on the outside of the perimeter except the garage. And then once that's done, then we come in after all the utilities are put into the house, and then we come in and we shoot the insulation, the foam insulation. But during the procedure, backing up a little bit, we go up, I have my framers go up into the attic. We close off the garage, we close off the front porch and the back porch with 2x4s, and then Barry comes in with this sheeting cloth, and he puts it onto these rib cages, I call it, and then he sprays foam on that. So now, with the foam insulation that we're looking for, we heat and cool just the cavity of the living space of the home. All right, going back to the outside of the house, I put this radiant barrier insulated wrap on my house. It's a foam packing, it's a bubble wrap, and we put that on there. So with the radiant barrier on that, when the brick is on the home and you're living in it, when the brick heats up from the sun, that brick is going to, just like an oven, is going to continue on going to the house. When it hits that radiant barrier, that foil backing, it throws it back to the brick, and that keeps the heat from protruding into the house. So that kind of differentiates me quite a bit from some of the other builders that doesn't do this. And as I know right now, I'm the only builder out there. There may be one other that does the radiant barrier that I do. So, and that's what kind of differentiates me, plus the different qualities that I put into the home for you.
Okay.
Or my customers.
Thanks, David. Barry, there was a couple of things that David mentioned that I'd like you to elaborate a little bit on. This whole concept of this super seal, this sounds pretty important. Can you help us understand that a little better?
Yeah, engineers through time have tested on homes, and they pull a blower door on a HERS rated home to get their HERS rating. And a super seal, a home that is super sealed versus non super sealed, is like drawing air the size of a brick, is the way they explained it to me. If you take and super seal the home, if you don't have a super sealed home, then you have an opening about 3 by 3, the size of a 3030 window. The air is coming and exchanging through your cracks and through the crevices, the plates. So what we do is we go into a home, we seal the bottom plate, we seal the top plate, anywhere plates come together to finish the envelope that we start with our spray foam. Spray foam seals the cavity, but it doesn't seal all around the windows and places. So we go in and just finish it with a caulk seal package.
And that's basically what you call super seal.
Super Seal, Energy Star Super Seal package is what it's called.
So it's the equivalent of the difference of air leakage of a brick compared to a window.
That's
because
correct.
of that. That's awesome.
correct. Yep.
And another thing, to interrupt you a little bit, we don't caulk the windows and doors, we soft foam fill them
Correct.
to seal them off, right?
That's correct. We use a door and window spray foam to put around them. If it's a tight spot, we do caulk that.
Yeah.
But most of them had a 1/4 inch gap so that windows can move with the home, and that soft foam allows that window to move so that you don't get a crack in your glass.
Interesting.
That also comes back to the window company. If you hard foam or hard seal it, then that voids the warranty of the window. So we have to be careful of what we use in there in order to keep the lifetime warranties that we have in your house with the windows, which we'll get to that later on.
Okay.
And that'll be like a spray can foam, like open cell type foam?
It is actually a closed cell, but it's
Okay.
made specifically for doors and windows. It's a low expansion. Where you see can foam, typically it'll expand hugely when you spray a little bit of it out. This is designed for doors and windows to not warp them.
Barry, another point that David made that I think is pretty significant, or was as we were looking at this whole concept of insulating the entire envelope of the attic rather than just the decking, as typically in every other home I've ever had. Can you help me understand a little bit more about why that's so important?
The envelope of the home. Let me go to the whiteboard and make a drawing for you and make it real simple. I'm a simple guy, so it makes it simpler for me. If we have a home and you have a porch and you have walls and you have a garage over here, I'm not a good artist, but we now insulate the roof line, separate the house from the garage with the cloth that Dave was talking about, and on the porches, we separate the porches, coming down the walls, we're making a complete envelope around like a cocoon. Homes have sheetrock typically right here, and you have duct pipes running through the system. So if we insulated right here, like we did in the old days, then we have these air conditioner pipes, which we have the geothermal pipes now. They're running in a hot attic or a cold attic, depending upon if it's winter or summer. So if you go outside and you get a drink out of the water hose, you want to get a drink of cool water. Well, you want cool or warm air, depending upon the season, coming into your home. And to make that happen now, they put these duct pipes in this envelope. And again, guys, if you've got a water hose laying outside and you want to get a cold drink of water when you've been out at the barn, David, or you've been gardening, or you've been messing with your horses, you want to get a cold drink, you have to let a 100-foot hose purge. The hot water, the sun has been sitting there baking, is going to be hot. You want cold water, you let it purge, you get a cold drink. The same thing happens here. This duct pipe is in a 160-degree attic. It has to purge all that hot air into this home. Or in the wintertime, it's cold air. Whatever the ambient temperature in a typically insulated attic is what's going to be in that pipe. So if we let it run, now with the envelope, you have heat and air within 2 degrees of what your temperature inside the home is, because your attic is within 10 degrees of what this temperature is. Make sense?
Makes sense.
It's good stuff.
And I think one of the things that makes it very unique is the ability with spray foam insulation to actually insulate that fairly efficiently.
That's correct. And it seals up this roof line. You know, there's so many roof line pitches and so much irregularities in
Yeah.
homes. It seals everything like a Yeti ice chest, if you will.
Guys, I assume that all these measures we're talking about is going to make this house extremely tight. I just have a question. How does the house breathe? Can somebody help me understand a little bit about how does the house get an air exchange and actually breathe? I mean, I know we want it tight, but there's got to be some air in there. Okay, Caitlin, can you help me understand that a little
Let
bit?
me take a run at it. What they typically will do and what they will call for is what they call a energy recovery ventilation device. And what that device accomplishes is allows the home to receive new air or fresh air into the home, but before it enters the home, the device allows the air entering the home to be pre-cooled and or preheated through that device. So that device, it helps the air quality of your home. So therefore, when you're looking at the humidity within your home, this device will help the humidity stay between the 40 and 50 range, percentage-wise is what you want. It'll also help reduce your overall amount of BTUs it will take to heat and cool your home because it's preconditioning that air.
So if I'm understanding you right, what it's doing is it's allowing my house to breathe. It's bringing outside air in, but it's transferring the BTUs of whatever, if it's cooled air in the house or warm air in the house, it's transferring that, so I'm not losing that energy efficiency that I've already spent a lot of money to achieve.
Right. Well, I'll try to give you a visual. You can, when you're bringing air into a tube, but you have a tube on the outside of that tube that's exiting out of the home, so you're exhausting the used air or the unconditioned air that's now exhausting from your home. It's heated and or cooled, so it transfers into the air coming into the home.
And that's all just a part of my heating and air conditioning system with the Geo system.
Yeah. And something that you also want to know and consider, that is a device, so therefore it runs on electricity, but it uses a minimal amount of electricity, which doesn't really add into the overall increase in energy consumption.
Thanks, Callan. Appreciate that. Barry, I've got a few questions for you. We'll try to button this up. I know everybody's got to get back to work, but first of all, help me understand the major differences, other than cost, between conventional insulation and foam insulation. I'm talking about bat, blown, cellulose, fiberglass, whatever that conventional market is that I would be considering versus this foam. Help me understand that.
Sure, we're a full source insulation company, so we have the bats, we have the blown, we have all the items. The bats, when installed around electrical wires, around electrical boxes, irregular configurations, they're not good for energy efficiency. Then you go to the net and blown or blown cellulose in an exterior wall, that's 30% tighter than the bat. Even though our blown fiberglasses and blown celluloses are 30% tighter, in the air you have hot air rising, in the cavity you have hot air rising and cold air dropping, creating wind wash, which is a loss of R factor. In a foam system you don't have that. So being raised in this industry, we've gone from nothing in the walls to now we're spray foaming the walls and then spray foaming the complete envelope. So with your question, that's sort of the differences of them. Foam being the most efficient and costing about a third more over a blown wall system.
Okay. Now, is settling, does that have any impact on any of this?
It does. If they're installed incorrectly, you could have settling of the blown insulations in the walls and the blown insulations, fiberglass or cellulose in the attic. It states on most cellulose bags that they're going to settle about 20%. Right off the bat, it's going to settle.
I've heard some skeptics talk about some stuff around foam, and I want to clean some of this stuff up. Some of the things that they've mentioned is that these homes that have foam insulation are going to have problems with moisture retention. Is there anything I need to be worried about if I go foam?
No, foam, the open cell foam we use in homes, actually vapor can drift out of that. It can go through and get out of it. If you take our foam and put it in a tub of water, it'll float, it'll never absorb water. But water can pass through vapor drive under hydrostatic pressure.
Okay. Now, you mentioned open cell or whatever, and I'd read a little bit about that in preparation.
Yes.
Can you explain the difference between open and closed and kind of the pros and cons of each?
Yeah, a home will move as it's being through time, contraction, heat and cold. So we use an open cell foam and that moves with the home. If we used a closed cell foam, there's a chance that it could crack away from the studs. We very, very seldom use a closed cell in a residential application. We generally use it more in industrial or oil field type of applications.
I'd like to step in a little bit of that too, Barry. One good thing about the open cell, it's 8 inches up in our rafters in that envelope package. But, we're in Oklahoma, guys. So we have a hailstorm and we tear up our roofs and everything else. And if it protrudes and we get a leak, that open cell is going to leak from where it began. It would drain straight through there. So you're not chasing. If it was a hard cell foam, it can get on top of that hard cell in between your roof and that foam, and it can travel anywhere in that whole house. You'll never find that leak. So
Interesting.
the open cell, the water, if you ever have a bad storm like that, that water will come through that foam right where it happened. So that's another good thing about that.
Dave, while we're with you, I think an interesting piece to me, lived through a horrible situation and more tornadoes, went through and looked at that, is I saw some things, and I'm going to ask questions because I don't want to lead you into it. Is there any difference with foam insulation in the structural integrity of the home?
Yes, there is. That's a good point. Because I did have a house hit in the El Reno tornado. And I talked to the engineer of OU about this during one of our seminars in the Green Building. And he said, I'm 10 years ahead of him because that foam actually glues this house together. So, and for instance, I mean, I've done some houses over in Moore, rebuilt for some folks that was in that tragedy. But in El Reno area, where the tornado came by, it wasn't a direct hit, but it was within less than 1/8 of a mile. It destroyed a friend of mine's place. But this house that I built there, Foam Field, it actually tried to twist it. Now, it blew all the west windows out of the house. It tried to twist the house because I had to fix a few cracks in the brick and the rock on the corners. That house stood. Houses around me, some barns, one of the veterinarians out there blew away in it, and my house is still standing. So that blew the engineer's mind.
Interesting. That's kind of a neat thing to know, living where we live, especially in the fact that I'm building in the Mustang Yukon area. So.
Yes.
Excellent. Thank you. Okay, guys, it's time to show me the money now. I mean, we're on a budget on this home. Miss Yvonne and I only want to put so much in, and I need to talk about some items here. All this stuff sounds really good, but I understand that it's more costly to go foam than it is the traditional conventional means. How much more is it going to cost me to put foam in my home?
We usually see it costs about 1/3 more.
Okay, that's good, because I've heard traditionally it's been around 50% higher. So that's came down?
Well, with bad insulation and R30 blown attic insulation, you're probably double the cost. But most people don't put bats anymore. It's a blown wall system, so that brings the cost to about 1/3.
About 1/3. All right, so if I'm spending 1/3 more, how much do I save?
Well, typically, like case studies we've been looking at, they're showing that you're going to have a 20 to 50% savings. And if that's the case, it's usually a 2 to 3 year payback. An engineer customer of mine, about 15 years ago, showed me with his evaluations of all the savings and case studies he looked at and the cost difference like we spoke about. He showed me that it was going to cost him $10 a month for the extra 1/3 more on his mortgage. Then he went and showed me in utility savings how he was going to actually be saving $100 a month. So that put 90 in his pocket instead of spending 10 on his mortgage every month.
Well, guys, with that type of analogy or whatever, I like that extra $90 a month. I think this is a very simple decision for us to go with. Caleb, I think I'm going to go foam with this house. And that will conclude for today, but join us next time as we start to look at windows, which is the third most important decision that I got to make on this house. Thanks.